In exercise 7.2.33, we're running a hypothesis test that is a two-tailed alternative hypothesis test. The not equal to in the alternative hypothesis is what makes it two-tailed. And the reason we're going with a two-tailed alternative and not a less than or a greater than is because we didn't necessarily know or think that the average weight or the average amount of tuna consumed per person every year is less than 3.1, nor did we necessarily think that it was more. We just thought that it was different. And so when we think that it is different, we choose to use a not equal to in the alternative hypothesis. So if we visualize what this represents here, we've got this test where they've claimed that the average amount of tuna consumed per person every year is 3.1 pounds, and we found that in our sample, the average amount of tuna consumed per person was 2.9 pounds. That produced a z-score of negative 1.15. The p-value, though, is not the area just in this tail alone below that z-score of negative 1.15, but it also is the area in this tail above a z-score of positive 1.15. So these two tails together make up what's known as the p-value. So what we have to do here is look up our z of negative 1.15. So we go to the z column and down to the row that has a negative 1.1. And since there is a 5 in the hundredths place, we go to the column that has a 5 in the hundredths place. And we follow that column down to the row that has the z of negative 1.1. And this is the probability that we would be that far out in the normal curve or further. But remember, that is the area in just that one tail. Because it's two-tailed, then that tail area is also 0.1251. So we've got an area here of 0.1251, but we also have an area here of 0.1251. So in a two-tailed test, we have to take the area that we get and we have to double it to get our p-value. So in this case, our p-value would be equal to 0.2502.